Okay, Naam, we have already 50 participants joining this webinar, our first webinar for the year for the Our Dealers. So I would like to welcome all our participants, especially our dealer, for joining us in this another training session. Thank you very much for giving us your time. I hope you will gain additional knowledge today. And Naem will be giving the presentation. This will be another recorded session. We will share to you the recording after the training, and we will share to you the PDF presentation of Naem. Okay, Naem, since we already have 34 participants, please start the presentation now.
Yeah, thank you, ma'am. And good morning, everyone. Greeting behalf of XY team. And nice to see you all again. I hope everybody is doing good. I just want to be confirm my voice and is okay, and you are able to see screen. Able-
Yeah, we can hear you properly.
Yeah, yeah. Thanks a lot. Thank you. As Ms. Irene explained, today we are going to be have a session about liquid measurement and as known as a transmission measurement for liquid measurement. So I'm just sharing my presentation. Okay, this is today's session agenda. So we are going to be have introduction about transmission measurement, and then we'll have little bit interpretation about terminology we use transmission and as well as transmittance. Then we'll discuss type of transmission measurement, then hardware requirement and compatibility with our Excite product line. And then also we'll include the series and transmission kit. And also we have calibration and measurement technique based on our Excite instrument. And then we'll have what all the attribute is available in I2C software. And afterwards we'll have live demo and hardware calibration and measurement videos. And then finally we'll have recommendation. So what all we need to do or we don't do it during transmission measurement. So here we go. As we know that we are in industry where color is matter. So we do color measurement. So if we understand color measurement, there are several kind of instrument which able to do color measurement. So like the densitometer, colorimeter, spectrophotometer. So nowadays it is much in practice spectrophotometer because of its consistency and accuracy and good repeatability and reproducibility. So spectrophotometer normally work in with two technique, which is called as reflectance and second called as transmission. So I think we all familiar how reflectance measurement is taking place. It is nothing but that we have one light source. That light source emit the energy. It will fall on object or it will stop on object, and some of the energy got absorbed by object, and some of the energy got reflected. And that reflected amount of energy got collected by detector analyzer. So this whole process we call as a transmission reflectance method measurement. So same thing we can see in our slide, first picture of left side of first picture. It is explaining how it is taking place. Simple method, not in deep. We are not talking about instrument autonomy. We are just simply explaining what is the process in while doing reflectance measurement. And second most usable technique in spectrophotometer to measure the color is transmission. So in this simple little change is there. If we have an object, we have a light source, we have a detector, but the light is going through the object, inside the object, or it's inside the material. So in this transmission measurement, energy emitted from light source and any light, it may be natural or maybe artificial like lamp or anything, that light emitted from light source, and then it will stop on object, and because of object criteria or characteristics, that light pass through with object, and then after pass through we collected the light energy that we call as through detector, that we call as transmission measurement. As we can see in this picture as well, that light source is a kind of sun. We have symbol sun. Then it is that light energy is coming and it touching the object and passing through inside the across the material, and then that transmitted light from one place to another, and then we collected last and that we call it through detector. So whole process is called a transmission measurement. So there is a simple method, simple difference between both. In reflectance, we are collecting the light which is falling on the object, and object is reflecting amount of the light based on surface or material characteristics, and that energy collected by detector or analyzer. But in transmission, we just collecting the light which is passing through that material. So this is a simple basic difference between both. And today we are just going to be through all the things about related to transmission measurement and how it is taking place, where we need to be used, what all instrument we can use, and what all the industry perspective or color attribute we have in our software. Yeah. Yeah, when we talk about transmission, so normally we referring to terminology. One is transmittance, sometimes we use it transmission. So we have to understand what is a transmittance or what is a transmission. So transmittance is nothing but amount of the energy which is collected after passing through the solution or material. That is amount of energy. It is called a transmittance. And transmission is nothing but this is a whole process uh, which is that energy may be light, or it is a light is transmitting from one point to point B. So whole process we call it a transmission. So if there is no difference, we can use both anytime. So just it to be, one is explaining the amount of energy and one is explaining the process. That's all. This is the difference. If we are wrapping both the terminology, it is nothing wrong in that. So here we have to be understand when we are doing transmission. So what is happening? So when transmission is taking place, lot of things is happening. Some light energy will come. Some of the light got observed. Some of the light got scattered. Some of the light got reflected. Some of the light got energy got transmitted, and some of the energy because of reflective index got bent. So it will, all those activities or behavior will be there. So to understand it simple way, we can see in our picture in our presentation. So here we can see that picture said that so multiple blue line is coming as a total energy or maybe incidental height. When it is touching the surface of object, it could be a plastic chip or maybe solution fluid. So immediately some of the light got absorbed, some of the light got energy got reflected, and you can see some that beam also got little bent. It is because of a reflective index, and then some of the energy got transmitted. We can see the last 5 rays. It is so whenever transmission is taking place, that kind of activities will be there, or it is a kind of behavior of energy when once we are doing transmission. So in whole process, what we that transmitted energy, which is we are seeing last 5 blue rays, that we have collected through detector, and then we calculate the transmittance well. So here with a simple formula to calculate this. So here we can see to transmittance we represent by T and observance represent by A. If you want to be calculate transmittance value from total light, so normal light upon total light, I0. So I0 it is a incident light, means total light, and normal light is a energy or light which is after transmission or pass through the material. And if transmittance we want to be calculated in percentage, we simply multiply by 100 by transmittance value. And if you want to be calculate a value, then it is log 10 total light divided by transmitted light, I0 upon normal I. And also there is a formula called calculate observance value from transmittance value. This is 2 minus log 10 T percentage, and A again second formula log 10 1 minus T. So this is a simple formula. This is to be understand because all these things is taking place by through software. So we just to be measure and everything will be available in software. To be understanding how to, what calculation is behind this whole process. To be understand for this, we just added those calculation. And we want to be add one more thing. Okay, this is a technique, scientific technique. It is how effective is this. We may understand that RNA, DNA test analysis also done through this transmission process. Blood test, forensic lab test, even corona test also. Some of these days we do transmission tests to verify the corona particles. So this much effective is this technique. But we will stick on how to do color measurement in transmission method. So, but just for understanding, we can understand how broad and effective approach, scientific approach it is in instrument. Yeah, so we are on color side. So when we do transmission measurement, and we are hearing a lot of things like total transmittance, diffusion transmittance, regular transmittance, direct transmittance. So these are different kind of transmittance measurement. So if just want to be do very clear, with total transmittance, diffuse transmittance, and luminous transmittance, all three are same. We can call them as a total transmittance. And regular transmittance and direct transmittance both are same. We can call as a direct transmittance. And why we are and we are referring total transmittance because it's because of it is understanding that the total means complete. It include all regular as well as diffuse transmission. That's why also we calling it diffuse total transmittance. Direct transmission and the regular transmittance because it is simple and it's straight. You will see in our picture. So here we have a left hand side picture. So we explain this. So first we will see this regular transmission, which is the upper part. So here light beam is coming straightly touching the object, which is clear. If you can see, there is there is a transparency, proper transparency, no haziness. So that light beam is passing through that material with seen as a straight light beam. So in this we can see there is a very least refraction or diffusion because of material. So that kind of transmission we call as a regular transmittance, transmission. And below the picture we can see there is a light beam is coming straight as like our picture. But once it is touching the material or object, it is the fraction in multiple light beam. It is because of reflection or diffusion, so we call as a diffuse transmission. Or it is because of material characteristics or behavior, because some of the material which is not able to be give the straight light transmission, and that light beam got fraction in multiple beam, and that is called as diffuse, and it is diffuse transmission. To be understand simple way, if anything which is a 300 or 400 nanometer material or particles, which can possible to be give you least diffusion or reflection, So because of that, you may get that regular transmittance, and which is having the molecule size or particle size more than 400, which material maybe give you that diffuse transmission, and it will because of particle size, that light beam, it may be scattered and fraction in multiple beam. So if it is a 300 and that's fine. But again, for simple way, we can say if it is anything from dyes or clear thing, then it will do mostly regular transmission. If it is something which is with pigments or polymers with the higher particle size, it will do diffuse transmission. So here now, when we are talking about transmittance measurement, so we should know that which instrument is capable to do transmittance. So as we see our Excite complete product line, so there are several instruments which is multiple geometry and multiple technique method compatibility. So here we have some of the instruments which is capable to do only reflectance, like CI7500, CI6, CI2, 62, 63, 64, and CI4100, 4200, and CI5 series, and exact, meta view, multi-angle. Those are the instruments only working with reflectance mode only, reflectance technique. There is no transmission measurement compatibility. But there are three instruments, and we can see series which are able to do transmission as well as reflectance. So there are 76, 78, 7600, 7800, 7860. So these are the three instruments which compatible with both the method. We can do reflectance as well as transmission measurement. In this case, we have to understand if a customer is asking, okay, I need to do transmission only, then only we have to recommend 7678 or 7860. Or if the consumer want to do both, then also we need to recommend all three only, because they have both the compatibility. If a customer have used for a single thing, then maybe also we can recommend. If customer have both the things, transmission and reflection, then also we can recommend. If customer need to do only transmission, then also we can recommend this. And one more thing, when we are just going for spectrophotometer recommendation or suggestion, if we are working with customer, we can analyze customer requirement, and we can see his process. If sometime, for example, if I will take the example from dyes industries, so they will buy two spectrophotometer. One is spectrophotometer for reflectance, one is spectrophotometer for transmission measurement. So we can see the feasibility, and we can ask the user, okay, you are doing both. So better, why not you can buy the 7800, which will give you that both the method measurements. So that way it may be feasible for them, and because accuracy wise is very fantastic, because we can compete any instrument. So in that way we can recommend and customer go with this instrument, and then he may save some cost as well. So it is a benefit to customer as well. So when we are recommending the transmission instrument, then we have to be understand it will come along with transmission kit. It will not come default. So when we are ordering that 767800, so we have to be add transmission kit as well. So if that kit will only enable, then only we are able to do transmission measurement. So here we can see this transmission measurement series. So one is film holder. Yeah. Sorry. You may be able to see this. Yeah. Sorry. Yeah, here first is film holder with small aperture, and second is again chip holder with micro aperture, means very low. It's around 3 to 6 mm, and then third one is again chip holder, which is a large aperture. It is around 25 mm. Then fourth is platform for to hold these holders. Either it is a liquid holder or it is a film holder. So both the holder is possible to be set on this platform. And then fifth we have a liquid cell, and it is for weight and solution measurement. And then we have a sixth white tile, and it is always used for transmission calibration as well as for measurement. So it need to be placed this white tile in aperture side where we do physical sample measurement. So once it will be placed, it will make geometry in diffuse condition. And black card, it is a black card. It is this card is normally used for calibration, so it will help us to do 0% transmission measurement while doing calibration for transmission. And the eighth is white coated aperture. White coated aperture. So in normal reflectance, we have aperture with stainless steel, and then there is no coating. That is fine. But for transmission, it must to be used that white coated aperture, as we can see in picture. So it is going to be placed all the time. Either we are doing calibration or measurement, transmission measurement. And ninth is Kuwait. Kuwait, which is kind of cell to use for liquid measurement. So here in this we will fill the liquid or color solution and do measurement. So there are several kind of Kuwait sizes there, but majorly it use 10 mm. So by default it is coming 10 mm, and if it is a requirement for 20 mm or any other things, so that we need to mention especially while doing order. And one more thing I just want to be add, if 7800 we are ordering, so customer have a flexibility to choose the mode, because if he can order 7800 and it is not compulsion to them, okay, immediately they need to buy the transmission kit. Maybe after 1 year, 2 years, they want to do they started doing transmission measurement, they can buy afterwards as well. But in other instrument or competitive, so if you have to be include immediately in same only. For example, if we talk about DC instrument, so if they buy 1000 and after 1 year, 2 years, they will go for a transmission measurement. So they can't switch to that. They need to buy 1050. So this is kind of difficulty, and we have a flexibility in that. And we have in our instrument we have multiple aperture transmission measurement, and that also it is not available with other manufacturer as well. And if we'll see 4, 5, 6, 7, 8, and 9 for textile dyes and solution measurement. If we want to do textile dyes or solution measurement, so that 4, 5, 6, 7, 8, 9 parts are actually enough to do that kind of calibration and measurement. And if you want to do film or chip and has measurement, then we must have 1, 2, 3, 4, 5, 7, 8. So right now it is not distinguished, and we doesn't have two different kit. But in future, I think we are about to have option to be choose if we are going for textile kit or maybe non-textile kit, or if you want to take whole kit, that is also fine. So that I think that option will be available soon. So here is an instrument about excite instruments. So if we want to do direct transmittance and total transmittance, so how to do total or direct transmittance in our excite instrument? So we can see total transmittance, that sample, it must be near to sphere. We can see in picture that yellow chip, it is along near to sphere. And then if you want to do direct transmission or regular transmittance, then that sample or the solution must be near to lens. So it is a thing, and then again, in which thing we have to do. So normally when we are doing direct or regular transmittance, normally you'll get instruction, okay, we have to do the total transmittance or regular transmission. If you doesn't get the instruction and we want to be clarify ourselves, okay, which which method we need to be used. So we can see again, as we have discussed in the previous slide, if it is a particle size of material, it is lesser than, or it is a clear or solution, then we'll go for a direct transmittance. If it is a particle size higher and we'll go haziness or invisibility, then we will go for total transmittance. And basically, it could be manufactured by pigment or anything which is a higher particle size. So this is a simple understanding about that. And basically, most of the times we are getting the recommendation from vendor or buyer, okay, we need to do total transmission on regular transmittance. Now we talk about hardware and about transmission kit. Then now we are talking about the color attribute in our color icon for. So when we do the transmission measurement, so we can use any colorimetric data for we can refer or we can analyze the things based on that, like CI, LAB, CH, XYZ, delta I, strength, metamerism, color constancy, and all. And the transmittance percentage, yeah, it is again very most important attribute for transmission. This is now we are going for customized attributes which is mostly used in transmission. So one is the transmission percentage. Yeah, it is a very most important parameter. So when we are doing the transmittance, so we must know that how much transmittance happening with this material. So that also we can calculate in our spectrophotometer. So there it is a directly available checksum as well as capital CI trace to mass value Y value that also is referring total transmittance. So that we can refer. And in all the industries, like it is a glass or water or maybe solution, color solution, or maybe transparent and translucent things, flat material. And further we have color value. And this is a second most important parameter attribute. And we can say transmittance and color value directly we are getting through spectrophotometer because it is a direct calculation from transmittance value. So in this, it is also known as ABS value. It is represent color depth and mostly used in textile dyes and pigments measurement for solution measurement. Now further we have very industry specific attribute like Gardner of say bolt or STM color. So Gardner and Alpha two very use in the industry. So Gardner, I think maybe it is a globally known color scale standard, which is due for color solution measurement and scaling. And generally, it is developed in 1920. And with that time, it is defined small x, small y, chromacity values xy, and then based on that, it is defined the 1 to 18 color is different index color. You can say color scale, and based on that, we will measure the something. It will give the okay this color solution have a 5 or 8 or 18 Gardner scale value, and based on that we are deciding okay it is good for our use or good for this particular process or not. And then later on in 1997 there is again one more standard came up. It is ASTM D6166. It was using same background as actual Guardian color scale, but it came with 10 mm path cell measurement method. So both are broadly used, and there is only difference is first one is that we call as ASTM 1544. It is with 20 mm path cell to it, or ASTM 6166. It is 10 mm path cell. And other than that, everything is same. And it is again in both the cases they are applying the same small x, small y, CIY values, which we call as a chromacity coordinates. And it is used for acid, for resin solution, for water clarity as well. So nowadays I have seen in Gardner and AFA, because in India also people are asking these standards for water discharge. So if it is a sea discharge, mostly they are wrapping Gardner, because Gardner have a scale from clear water to dark reddish, dark yellow and reddish greenish tone, which is maybe highest. And alpha is having little low scale, so that's why we call as in-house discharge. We call as public discharge. So in tasting, Gardner, we can see still in upper side there is a 3, 6, 9, 12, 15, 18. So it is and the same color strip also along with that, so we can understand if it is a solution color is this much. So this could be a Gardner color scale. And second, we have alpha. It is a kind of same inspiration from Gardner, and but it is have different calculation. And like we can see, both are working with optical density method only, like transmission method, but have different calculation, which is working that alpha is working from 0 to 500. We can see that 0 means clear water, and if it is a 500 alpha, it is a little darker clear yellow color. You can see in picture. This is a alpha scale, and usually it is a formed by American Public Health Association for determining water quality. And nowadays, I think in India, and we have seen in our region that people are using this one and before discharging or ETP use. Now we have further more industry specific attribute like Saybolt color and ASTM color. Saybolt and ASTM both are having same industry. Both are majorly used in petroleum industries, where we do that fuel color check, kerosene, naphtol, solvents. It's it is majorly both in standard use in petroleum industry. So we can say, okay, we can recommend our spectrophotometer in industry, petroleum industry as well, based on this use. And it is a compulsion, because whenever they are petroleum industries making their product, they have they are supplying their product with specific color and norms. So they must use this instrument. Yeah. And the Saybolt color, it is a referring the standard ASTM D156 and D6045, and it is having a scale from 30 to -16. So we can see here in our picture Saybolt color. It is a if it is a 30 or more, almost clear and no chromatic contamination, and if it is going till -16, it is a slight little darker yellow color, which is yellow chromatic tone. And same for STM color, it is referring that D1500, and it is a D1500 majorly used in petrochemical industries, and ASTM 1524 is slightly, but people know 1500 more than this one. And here in which we have a scale from 0 to 8. 0 it almost clear oil or liquid, and if it is 8, it is a large dark red color. So both are used in specific petroleum industries, and along with that, if we would want to do Saybolt color and ASTM as well, and
Hello, Naem, are you there?
yeah, sorry, I got to go. Is it okay now?
Yeah, okay, you're back. Thank you.
Yeah. Hope I didn't miss. Yeah. It's, now further we have the heads, that is we call as ASTM 1003. So first we have to understand head is very important parameter. doing a haze measurement. So haze is very important in plastic and chip industries. So who is producing plastic and polymers. So for them product or things, they will check opacity as well as the haze. So in this, we can say if we want to do color as well as clarity of the material, transparency of the material, we need to do haze measurement. So there is a thing. It is a little different from other simple measurement. Here we need to be measured simple with over white over black. So we can say कि every sample we have to measure two times. One time we have a specific white tile in sample port, and then we have a black trap on sample port. Then it is kind of a diffuse and total transmission measurement, and based on that we will calculating the ratio and then telling how transparency this material have. That is a simple haze measurement approach. And there is a standard ASTM D1003. So it is a standard which is coming with two methods. One is hazometer, one is spectrophotometer method. So hazometer, it is using unidirectional sphere method, and then another one is spectrophotometer sphere method, sphere method to do measure. So in both the both the measurement has come as per qualified as per ASTM 1003. And we can see that color chip, and then that pot with the transparency. Then we can see two white chips. These for measurement for haziness, and then this qualifying. So all the kind of different product we are using as measurement. And then we have light blocking. It is a very specific attribute only for textile. So there is a two method nowadays in home textile is using for light blocking. One is light blocking TM203. Second one is searing method. So in there we have to be understand there is a little difference. If we are doing that same kind of over white over black measurement in reflectance mode, that we call as searing method. And if you are doing that light over light over dark measurement in transmission method, then it has become a light blocking method, TM203 method. So nowadays it is very used in, and we have got several requests from industry who is doing that home textile business, and they will ask, okay, we need to be know that our spectrophotometer can do TM203 light blocking measurement or not. Yes, our spectrophotometer can do the TM203 light blocking measurement, and this is a kind of nothing but it is again check the for window covering and home textile material or textile, either it is a woven or non-woven or knitted fabric. We can do TM light blocking measurement. It is, for example, if we understand, okay, we have window and open area in our home. So because of things, we can't completely close them. If we have like a metal wood or metal glass window, we can close it, but we're not able to get the natural layer. So people are using that cloth and bind to get the natural layer, and it will hide the privacy or anything. So people are, that's why they are using light blocking as well. So they want to know that okay, this material is able to give that our healthy natural air as well as block the vision from outside. So that for that they are doing that light blocking measurement. So in this also that we have to be measure that fabric sample, which is used or maybe recommended to be go with that light blocking measurement condition. In this, again, we have to measure over white over dark, and this light blocking measurement is taking place in total transmission method only. And we can see it is a for specific, either it is a knitted or woven, we can do light blocking measurement. And if it is a messy or is having fabric or textile material is having hole, so that material is not recommended to do light blocking measurement testing. So now till there we have finished our theoretical part. Now we are going for our live demo as well as our hardware videos. So if anything in before that, you please suggest me. Otherwise, I will go ahead with the live demo.
Yeah, Naem, I just want to have a recap before you go to this video presentation.
Yeah. If any question till now,
Yes.
or shall we proceed?
There's no chat question so far, but I want to
Okay,
select
that's good. Let's go ahead.
Maybe
So
I
now
have one question.
Naem, just a moment.
we will
Naem.
have that live demo about IQC software.
Hello, Naem, can you hear me? Hello, Naem. Is there a question from everyone, anyone from the audience or participant?
Irene, we have a question.
Please go ahead, Naem.
Okay, for 3D samples or
Yeah.
irregular shape objects that requires transmission, like bottles or plastic bottles, do we have a holder for that?
Sorry. Can you please come again? I lost your first part. Yeah, please come again.
Okay. Can you repeat again the question, please?
Okay, do we have a transmission kit for irregular shape objects or 3D objects such as bottles, plastic bottles or glass bottles?
Okay.
Yeah, this, yeah, we have some customized thing as well in this. So in that, what we have to do, we have to be check the product.
Okay. Second
Yeah,
question.
okay.
and and then we will have something for that as well, because we have some customized thing as well for our flow through solution. Also, we have a different thing, and for big big size plastic chip and plate, also we have things. So there is something will be there. So you please share those pictures. So maybe we'll have something for that as well.
Okay. Second question.
Hello.
We have
Is
second
it okay
question.
now?
One more question, Naem.
Hello.
Okay,
Hello,
second
Naem.
question is
Okay, go ahead.
we have a
Hello.
customer. Yes, we have a customer who is producing car tints.
Hello. Ma'am, I'm audible.
Hi, Naem. Can you hear us?
Hello.
Sorry. Yeah, I can hear you well. I'm just trying to get in touch with Naem. Naem, are you still
I
there?
lost your voice. I'm not able to hear anything.
Naim,
Naem, can you hear us? Hello, Naem. Can you hear us? Okay. Can you hello? Who's I
Yeah.
think
Yeah. Yeah. Yeah.
Naem,
Sorry. No. Yeah. Yeah. I got. Back.
are you back, Naem?
Yeah. Yeah. I'm back. Yeah. Yes.
Okay,
Yeah.
we have another follow-up question.
follow-up question, Naim.
Yes. Yeah. Please.
Regarding one customer of ours that is
Yes.
producing car tints.
What is this?
It's an OEM company
Okay.
who is producing car tints.
Cartons. Okay. Yeah. Cartons. Yeah.
Okay. Currently, they are using 361T, our 361T. how can we convince our customer to move into this instrument?
So what normally they do now? So what is their basic requirement?
Yeah,
Basic use.
yeah, the 361T, I can help you, Naam, because
Yes.
361T is a transmission densitometer.
Okay.
Okay, and this
Yeah.
device is using a reflectance mode, and there might be some similarity, but in terms of data measurement, okay, I think I need to verify this there is a substitution for transmission measurement, because 361 is a transmission densitometer. So the principle of measurement is different because this is a spectrophotometer. Let me check with the product manager if we can have a suitable replacement for the 361 using a reflectance or transmission mode of measurement.
Yeah, I can see that the measurement with this transmission spectrophotometer can be more accurate with the different shade of tints that they produce, not only the
Yes.
thickness or the density of the tints.
Okay.
Correct. Yeah, I agree with you. But you know, the calculation on the densitometer measurement, that's I think we need to verify. Maybe we can do some correlation, or we have to ask for further assistance with regards to this transmission measurement using a spear device.
Yes, I think it will be best that they move into a more scientific measurement of sophisticated measurement of their that will include color of the shade of the tints and the
Mhm.
density of the
Okay.
tints.
Yes, Amel, thank you for asking that question. So we will take note of that.
Thank you, Irene.
Thank you.
Okay.
And Naem, just want to emphasize, because you did
Yeah.
mention before you do the video presentation, just to want to emphasize, to confirm
Yeah.
that our solution in terms of transmission measurement is very flexible. That just in case the customer decided to purchase the 661, those transmission measurement like CI 7800, CI 7600, and they did not use transmission at the moment, but they want to use it in the future. So X-Rite, they just have to buy additional transmission kit, and we have all the different sizes for different size of the product. While our competitor, I think what Naem has mentioned earlier, that is not possible. You have to make sure that you are going to use transmission in the future. Otherwise, you have to buy a newer model. And in terms of aperture size, they are not that flexible. Naem, is
Yes.
that correct?
Yeah, absolutely. Yeah. I agree with you. Okay.
Correct. So this is for competitive situation. If you're competing with our competitor, then at least you know that our solution is very flexible. Okay. So thank you.
Thank you. Thank you. And now we are moving to our IQC live demo. So here, I think, okay. And now I'm sharing IQC software. Yeah. So this is our IPC software. I think we all familiar with this. So as part of
Naem,
instrument. Yeah.
sorry, Naem, we cannot see. Are you sharing your screen?
Yes, I shared on my screen. We are not able to see.
No.
No, we cannot see it.
Yeah. Okay. Just a minute. I think it is taking one. Yeah. Is it okay now?
Yeah, your start to share. Okay, we can now see your software. Okay.
Yeah, thank you. And as part of our presentation, it is about our IQC software. So I think the basic thing we know that how to configure instrument and how to do things. So first we will start from calibration. So, so in this, I just want to be explain some of the things. We also in software also we have a option to be choose which method we want to be go. So in calibration we have to be decide which calibration method we need to do. Reflectance we all know. For regular, either it is a specific recommendation from buyer or customer, or otherwise we are doing anything related to dyes or liquid or clear, then we should go for regular transmittance. If it is we are doing anything which is a SE or not clear and which is with the higher particle size, then we should go with the total transmittance. And fourth one, you can see it is a second, third, and fourth one is hash. If we want to do particularly hash measurement, and then we should select this hash measurement option. And this is not that it will give you that hash measurement. It will give you that colorimetric value as well. So once we are doing hash measurement, and you will get. So once we do calibration measurement, then standard or trial measurement is same as we do in reflectance mode. First we can measure the standard, then we can measure the trial, and then we can check the delta value as well. So this measurement is same as we are doing, but in this to be understand, we are placing the sample in near aperture side outer near sample port, but in liquid measurement we have to be keep the solution or material inside the kit. That we will see in the further video. And there are just want to be add attributes. So here we can see that LABCH values, that is a color value. I'm just these color values. So majorly that the SWL used in the transmission measurement, that is we called ABS single wavelength or lambda max value. And then hash measurement. If we are doing hash measurement and we want to check the what is the hash percentage, so it will give this. We will refer this value, and it will tell us. This this value is in percentage, and based on that we'll check. If it has value is more than 95, then we'll say that that material is near to opaque or opaque. If it is around 70, then we can say that material is translucent. If it is less than 30 or 20, then we can say that material is almost transparent. And but again, we just want to be adding things. As measurement for single sample itself, we have to do 2 times measurements over white, over black. Then other color attributes we have. So just want to be explain that all the color group what we have discussed, like Gardner, for the STM color, Bolt, and LABCH. These are we all know that LABCH, XYZ, XYZ, and also that this capital Y, if we want to, if we are doing transmission measurement, then it is playing very important and norms. People referring capital Y value as a total transmittance ratio, and based on that we can understand how, yeah, it is also based on its calculation, it is represent the clarity about that, and it will have to be understand with the total transmittance or maybe transmission ratio. So these are the specific attributes we can use, we can switch, or whatever you like to be have, we can have in our IQC. And interpretation, what we have explained in presentation is like that, and other colorimetric LED, LCH, XYZ, all is simple interpretation as we have in reflect. Okay, this is about IQC software. Another thing, if you want to do the illuminate, another thing that is the same as we were doing in reflectance mode for IQC software. Tolerance, that also we can change. It is the same. Other than this, everything other than calibration attribute part, all are same as what we are doing for reflectance things. Okay, now we are moving to our hardware and calibration. Because we doesn't have right now, it is not possible to be have hardware and do calibration and do video call. So we have just added 2 videos for calibration and measurement, and hope, I believe that those will able to be explain things how that it is taking place, calibration and measurement for transmission. So I'm just going to be start those one. Are we able to see this one?
Yes, Naem, we can see the video presentation now.
Yeah.
Okay, but we cannot hear the back.
Okay. Yeah.
There's no sound on the video. Naem, are you there? So actually, while we're waiting for Naem, we have a lot of video channel on YouTube showing a lot of different application. Like for example, what you see right now is regarding the benchtop transmission measurement on how you set up the CI 78, 7600, 78, 60 on in terms of the transmission measurement. So you can see this is an example of those transmission plate that is included in the transmission kit. Now, we cannot hear the voice of the video. So I'm just trying to explain to them as what you see. And this is how they set up the calibration together with the, okay. So this YouTube channel, we can share it to you. You can also go, if you have your YouTube account, you can find X-Rite color support where we have a lot of this YouTube channel presentation. So right now it's doing a transmission measurement for those who have not seen transmission measurements. So right now, the Spectron white cup is being installed, and this is going to do some calibration in terms of total transmission mode, which is against the sphere. So you can see here, this holder is now positioned against the sphere, and that is what we call transmission measurement, total transmission measurement, and is doing a calibration with the blacking. And right now, he's doing a direct transmission measurement. So you can see here, it's moving against the lens. This is the lens part, and you can see the light that is coming out from the device. So you can see the status that is now being calibrated.
Yeah, thank you. Thank you for having me.
Okay.
And now we have a so uh, now we have another video which is a little lengthy. It is around 12 minutes, and it is going to be include calibration as well as some measurement in transmission and for total transmission as well as liquid measurement.
Naem?
Yes, ma'am. Yeah.
Okay, we cannot hear the video. Okay. So this you're showing the realistic pass-fail tolerance, right?
Oh, sorry.
Anyway, these are some of our video channels. So X-Rite Color. So you can see here, our YouTube channel is called X-Rite Color.
Yeah, now we have transmission.
Yeah, we cannot hear the video.
I
Anyway, this is Tim Mao. He's the application manager from North America, and he's now showing you some example on the transmission measurement using our 700 series. Okay. Anyway, we will give you the link to all of this video. I think it's in the NAM presentation also, right?
yes, actually.
This is the transmission kit. This is how does the complete set of our transmission kit. So he's showing you the spectralon calibration white tile. This is the blacking or the black trap for transmission or blacking. This is the only one cubet. Okay, and the different this will hold the what we call the sample platform for the different aperture size. So there is a magnet here that you can simply attach to the bottom of the transmission compartment of the CI 7600 device or instrument. So these are the aperture plate. And you will notice the aperture plate has a white surrounding. So if you're going to use the transmission measurement, make sure that the aperture plate has a white near the sphere to cover the whole sphere. That's why it has a additional white ring. And this is how you hold the transmission liquid. Then you attach this to this adapter. It's adjustable, so you can adjust. Okay, so she's showing you on how to adjust the cell on the platform. Okay, showing you the black backing. And this is where you position depending on your aperture plate. So we have the 25, 10, 17, and 3 mm. So depending on your device configuration. So this, we are the only spectro, I think, that can accommodate different sizes in terms of transmission measurement. So 3.5, again, is an optional. So you have to purchase this separately. So if you're measuring film, so you have to position this both of this 25 mm so you can measure some flat samples. Okay, that's the smallest part, that is 3.5 mm. Okay, so now he's going to do some measurement, showing you how to use the device for transmission measurement. So that's the compartment. You have to lift it up. The safety pin, okay. Then you can position in between the transmission compartment. So this is the transmission compartment. Okay. Doing a direct measurement, you position this 24 plate against the lens. And then on the opposite is what we call the total transmission measurement against the sphere. So you have to replace the plate with the transmission plate. So you see this one is the normal one does not have the white circle, okay? And that one is the one that has the white, okay? So this one will complete the sphere. So you have to put that in. So you have to make sure you have the correct plate, aperture plate when you do the transmission measurement. So this is a different white. This is not the same of the calibration white that we use for our reflectance measurement. This is only used for the transmission measurement. So we call it the spectralone standard. Okay, it's doing some calibration on the device. Okay. So that's how you position the black backing or blocking. Okay, we call it blocking. What do you think? Will he measure total or direct measurement? So for this type of plastic, it's not transparent. It's a bit hazy or a bit opaque. So he will use the total transmission measurement. So depending on the sample transparency, if you have that kind of sample that is not 100% transparent, then you have to do total transmission. Direct transmission method is normally used for clear measurement or clear film or clear samples. So you have this curve here. So it's showing you some big samples that we can accommodate. So again, if you notice the sample, the plastic sheet is a bit opaque, not really totally 100% transparent. So again, it's a total measurement mode. This is a close-up look on how the sample is being positioned. Okay. So it's showing you that if the sample is really very difficult to hold, you can use the control panel to take the measurement. So you have to set this up in IQC software. And you can see this laser beam. Okay, so you know which position is being measured by the spectral. Okay, so now you can take the measurement there. Okay. Anyway, we are going to share to you the link on how to access all this YouTube channel support from X-Rite support channel. So we have two, X-Rite Color and X-Rite support channel. Okay, Naem, you're back?
Yes.
There is a backfeed. Okay.
I think now is it okay, right?
Yeah, you're now back. Yes, Naem, please go ahead.
Yeah, thank you, ma'am. Thank you, Ms. Irene. And sorry for this video and this we are not able to be able to hear this voice. And but we will share, as Ms. Irene explained, that we will share this video link. And if anything further, you please reach out to us. And further,
Yeah, now Patsy is sharing to you some of the link. Okay.
yeah. Yes. So we have seen that IQC software live demo and as well as transmission, calibration, and measurement YouTube videos. And then finally, we have some of the recommendation. So whenever we are doing transmission measurement, so there is some limitation to go with this measurement. That material must be translucent or transparent. If material is opaque, then it is not recommended to do transmission measurement. And second one, as per BS Lambert law, that if we are doing any transmission measurement, either it is a solution or solid, if it is a ABS value is between 0.2 to 0.9, it should be 0.2 to 0.9 between. If it is more than that, you can measure, but it will not give you the linear result or relative good result as it with we can say it with effectiveness, that effectiveness will not be there in the result. So in this case, what we can do, we can measure the sample, and if that sample have more than zero point 0.9 ABS value, what we can do, we can dilute or it is for solution, we can dilute for extend to make it is that value in between to fall between 0.2 to 0.9, and afterwards then we can we have diluted, and that way also it will work very good. And transmission should be between, yeah, and whenever we are doing transmittance, and we can measure anything, but it is recommended which have that ability at least to transmit 10% to 90% energy, to use those material only, either it is a liquid or it is maybe fabric or it may be a plastic or chip. We should use that kind of material only for transmission measurement, as we have said in first point key that it is that translucent or transparent, and that kind of limit is with percentage. And transmission measurement we can do for quality control as well as for formulation. So and quality control we can check delta E, LABL, CH, XYG, strength, metamerism, ABS values, and transmission and other industry perspective color attribute like Gardner, Alpha, Bolt, ASTM color, has measurement, light blocking. and we also can do based on that formulation as well with the transmission measurement. So in that also what we have to do, we have to be prepare the database in through transmission mode, and then we can prepare the primaries like we have to in reflection. We'll primary means multiple concentration data through transmission measurement, and then those we can define as a colorant and all, then we can go with the matching as well. So that is also one more effective method before formulation. It will have very good result as well. And finally, we have that stent and tile must be measured in same time. For instance, it is highly recommended whenever we are going to do transmission measurement, then that standard and batch or trial should be measured same time or instantly, or maybe same time at well, this end standard measurement and this end trial and batch measurement, because then it will avoid any kind of uncertainty or any kind of deviation. And most of the times, if you will see in dyes, the solution, so when where they are going to dye solution measure transmission calibration, so they will prepare instantly a standard solution and batch or trial solution immediately, and then they will measure both at time. First is standard measurement, then immediately batch measurement, and they will do uh, delta evaluation or strength check everything. So this is our presentation, and then can understand it is having very broad approach to, and we can't even imagine. So I think maybe I just want to share one thing. Even we can use this transmission method in very wide way. And if, for example, if somebody is doing OBA as well as some of the doing the formic acid analysis. Formic acid analysis also we can do with this spectrophotometer, because that have ABS values on 460 nanometer, and then can see our spectrophotometer is working with 360 nanometer to 780 nanometer. So that way it is we can use in very broad way this spectrophotometer with the transmission combination. So there are a lot of things. If anything, you please let us know. We will always there to be check or go through and work on that. This is a presentation from our side, and finally, thank you everyone. And if anything, any question, query, yeah, please share. Let us know what we can do.
Okay, Naem. Actually, we have some question on the chat. I think from Krishna. Okay, okay. Does DC and Konica Minolta software also mention color value single wavelength for ABS, or they just mention ABS? ABS is absolute, not the plastic. Okay.
And the observance value, yes.
Absorbance value. Okay.
Yeah. So yeah, in DC and other institute, they are using K by S majorly, and then K by S it is only when it is a reflectance. If it is a transmission mode, then it has become ABS value. And then our X-Rite system, we have a color value. It is a common for whether it is a reflectance or transmission. And when it is reflecting, which is that value output would be as per K by S. If it is a measured sample is in transmission mode, then output will be as per ABS value. And then color value SWL is as equivalent to ABS SWL.
It says here, while switching mode from transmission to reflectance mode, it is compulsory to remove the transmission stand.
Yeah, because sometimes that in that if it is a film holder, then we have to be. I think yeah, we should remove. If it is recommended, if we remove it is better. Yeah.
Yeah,
In short, I have seen. Yeah, sorry. Yeah.
Yeah.
Sorry, actually.
Yes,
Yeah,
go
please.
ahead. You're breaking up, Naem.
Yeah, good. Thank you. Actually, some of the textile dyes manufacturer, they are using that platform as well, and with whenever they are doing transmission, they will do transmission. They will not remove the platform, and then directly they will switch to reflectance. They are doing, and then some of the people then maybe complain about anything. And one of the place we have observed some of the issues. So thing is like that it will mix. So that way we can suggest if we're going for a long time for reflectance mode, then we should remove transmission it inside the spectrophotometer. It is good because then it is no doubtful on measure. There will not be no doubt on the measurements. Yeah, please.
Ma'am, are you reading the question on the chat?
Chat, yeah, let me see. Chat.
Okay, we have one question here. How do you measure transmission for drape and curtain fabrics? How it is used for blocking light transmission?
Yes, and
Go ahead, Naem.
yeah, it is a we call it a light blocking method, and it is also it is verified with ASTM. That is a standard reference is TM203, and this it is in total transmission mode. So in this, we will keep that fabric in the, as we have seen that plastic chip near to sphere, and that we will measure it is over white over black. Over white over black means the first measurement will be with the white tile placed on sample port, and then second measurement will be black card or black sphere it will be placed on sample port. So based on that, it is checking it is light blocking ability of fabric, and that is also called as how that fabric is, how much blackout fabric it is. Yes, this is a method for that total transmission method.
Okay, one more question. Do we have multiple sample holder for different measurement?
Yes, we have for plastic and polymer chips, we have multiple size. It is around 6 mm, 9 mm, and 15 mm, 25 mm. But for Kuwait, it is only single. We have 10 mm.
Yeah. I think, what about irregular size, irregular shape, or transmission measurement?
Yeah, so as we see, it is a stretchable size adjustment in film holder. So if it is like Miss Tom is showing his video, we can adjust it is like if it is a one fit big size sample also that we can place, and we can check with our instrument beam position beam. So that will, and if it is something which is really difficult to be not used over there, then we have to be checked the feasibility to use those kind of material. Because again, if a measurement is okay, but we have to be checked how much accuracy we are getting with that. So that way, if it is a doubtful, we can check this sample and we can suggest what would be possible.
Yeah, we can try to customize depending on the instrument capability. Yeah, there is someone who's asking question.
I think background noise. Yeah.
Yeah,
Yeah.
I can
Okay.
hear some background noise. Okay, so I'm looking at the chat if we have some questions here. I think we answer most of them. Yeah, we have we also shared to you. Okay, there is one question. If the operator forget to change the transmission aperture during transmission measurement, would the reading be affected?
Yes, and if we are doing, if we are using white coated aperture for transmission, and then same aperture we can use for reflectance as well. So there is no issue, and it will not affect any measurement.
Yeah.
But
Yeah. Go ahead. Go ahead, Anna.
but we can't use without coated aperture for transmission.
Yeah. Yeah. Just be mindful. Of course, if you're doing transmission measurement, they have to, because depending on the size during the calibration, normally the software where if you're not calibrating it properly and there is a disagreement in terms on the setup, the software should detect that you have a different setting. Okay, if
Yeah.
the operator forget to change the aperture, depending on the size, then says here, okay, Patsy is also answering them. Yeah, might pop up an error message if you have a different setting. So remember, we always have a calibration mode, and the calibration mode controls the setting on the instrument. So make sure we train our customer on how to set up in terms of the different calibration modes. So we have reflectance and transmission. So as of this time, we don't have a spectrophotometer only for transmission measurement. We only we have only reflectance and transmission or reflectance. Now we have within our OPCOs or within Danaher, we have a sister company called Hack. Hack is doing the transmission measurement, but they are more into a more specialized application like water treatment. So they can also they can do this transmission measurement. So it's a more specialized application. Okay. Okay, if a customer have only requirement for transmission measurement, do you think customers should purchase CI 7800, or we have other instrument only for measurement of transmission? We have option both reflectance and transmission, so we may take price higher if the customer requirement is only transmission. It depends on the customer application because transmission has a wide application. So again, we have shown you some of the functionality in terms of transmission. So sometimes the liquid measurement can also be reflectance and also transmission. So there are some customer who would require liquid measurement in reflectance mode and liquid measurement in a transmission mode. Then our device can do that. Now, if there are some requirement that they only require transmission measurement, then I think we can recommend them some other brand. Oh, as I said, we have a sister company like Hawk, but we need to understand first the application. What is the specific application? Okay, if the application is too specific, like water treatment, and they have another data that they might require, then we can recommend our sister company to, to consider as an alternative if they only need transmission measurement. Okay.
Yeah.
Okay, so wants to buy kit for liquid only without film, when it is possible. Yeah, we yeah, we need to, it's always a kit. Okay, our kit is always complete for liquid, but for liquid measurement we only provide one transmission cell holder. So if you want to have more than one, that is an option. So it's another, you have to place a second order for the second transmission cell holder for liquid measurement.
Yeah.
Okay.
If there is a question, I think if plastic transmission sample is large and rugged, say, or not fixing transmission block, then how can we check transmission? Or if transmission block is open, then it is that safe to customer or not? Transmission in plastic usually to measure thin transparent plastic sheet. Yeah, Mr. Valu, it's depend on the sample size. If it is coming inside or it is easily normally in chip manufacturer they will prepare a small chip and to do check first edge or transmission measurement and then they will prepare the big things. But still, if it is some of the object will possible to be placed inside the transmission kit, but if not, we can share those objects to our team, and then they will suggest if anything possible. But yeah, in this case, it is at our 7800 have a limitation for particular size and dimensions. Yeah.
Okay. Any more
Yeah.
questions? I think we.
Yeah.
Mhm.
There is one question from John Alpha. For example, the black plate have some scratch or it got is accidentally broken. Can customer purchase it separately or they will need to buy the whole kit again? Yeah, I think you mean black card. Yes, they can afterwards they can buy purchase separately as well. It's as a single part. Yeah. Yeah, as Percy said, and if it is a scratch on the plate, it is no issue, and because it is only to block the light and to measure the 0% transmission, and so if it is a heavy scratch, that also doesn't affect measurement or calibration. Yeah, please. Any further questions, queries?
Okay. Any more questions? Hello. Can you hear me?
Yeah, we can hear you.
All right. Okay. So I think I don't see any more question, Am. As I said, we are going to share this presentation and this recorded session. So everyone who received the invitation from us will get a copy of this presentation. And we will have more similar Webex session for our dealer. If there is any specific topic that you would like us to, to do similar presentation, please let us know and we will accommodate all those requests and we will create a similar session. So I think we are towards the end of our presentation. So I would like to thank Naem for giving this very informative presentation, especially and also to our dealer who participate on this session. Thank you very much for supporting us, for keep supporting us. We do appreciate for sharing your time. And I hope you still continue to support us for more session similar to what we have started for this year. So we will try to do a more customized type of presentation so we can cover a much more wider subject or topics. So again, if there is no more question or if you have additional question, please feel free to contact us, Naem, Namashi, Patsy, Waluyo, and Kim. We will be able to support you and accommodate all your questions. So again, on behalf of the entire team, I would like again to thank you everyone. So we are now closing our session and thank you again for coming. And Naem, any last word from you before we close the session?
Yeah, thank you, ma'am. Thank you. And I just want to add, we have a very big application team, and if anywhere it is like a language barrier or anything, you please suggest that as well because our team is from uh, different geographical area as well, so we can suggest you in local language as well. So if anything like that, so any issues you face, you please share with our team. Yeah. Thank you, ma'am,
Okay,
and thank you everyone.
Yeah, thank you very much. So I'm now stopping the presentation. So
Thank you, everybody. Thank you very much.
thank you, everyone. Thank you for
Thank you.
coming.
Thank you. Bye.
Thank you.
Thank you, Mr. May. Thank you, Irene.
You're always welcome, everyone. Thank you.
Thank you. Thank you. Thanks a lot.
Thank
Thank you,
you.
everyone. Thanks a lot.